If the length and breadth of a parallelogram is made up of a vector, then we can determine the area of the parallelogram by finding the magnitude of the cross product of the two vectors, if A and B are those vectors. So why is this true? Let's try to prove that out. So let's consider a parallelogram. Hopefully that's manageable. So if this is a parallelogram, if the breadth of the parallelogram is vector A and the length of the parallelogram is vector B, while the angle between the two vectors is theta. In geometry, to determine the area of the parallelogram, all we need to do is to multiply the base of the parallelogram by its height. However, in this case, the base is simply vector A, and it will be the magnitude of vector A multiplied by the height. So what about the height? We don't have the height. However, it can be determined. So if the dotted line stands for the height, and I'm going to represent that for short as h, what do you think we can do to determine h? You notice that we can use some of the trigonometric functions to determine h. And the best function to use will be the sine function, as the sine of angle theta is simply equals to the opposite, which is h, divided by the hypotenuse of that right angle triangle, and this is the right angle triangle, in case you might be wondering, over the magnitude of vector b. Now, if we solve for h, you notice that h will be equals to magnitude of vector b multiplied by the sine of angle theta. Now, instead of having h, I would like to replace it with this. So that means in the end, the area of the parallelogram can be equals to the magnitude of vector A multiplied by the magnitude of vector B, then multiplied by the sine of angle theta. Now, what do we understand by the cross product? The cross product is defined as this. If two vectors AB are being multiplied together, then this will be equals to the magnitude of A multiplied by magnitude of B multiplied by the sine of angle between them, then multiplied by the unit vector n. Now, taking the magnitude of both sides, it turns out that we will have the magnitude of the cross product of vector A and B to be equal to magnitude of A, magnitude of B multiplied by the sine of angle theta, because the magnitude of the unit vector will be 1. That is something you should know. If you don't know, now you know. The magnitude of any unit vector is always nothing but 1. That is why they call them unit vector. Vectors with unity, just one magnitude. Perfect. Now notice that what we have here is the same as what we have here. So we can actually make a final conclusion by saying that the area of a parallelogram A is equals to this, since they are both equal to the same thing. To magnitude, the product of the magnitude of the two vectors. No, the magnitude of the cross product of the two vectors. I hope I put that properly. And that is how the formula is being derived. And that's where it's coming from. Now, sometimes you might be asked to find the area of this triangle. All you need to do in this case is just to take the half of the area of that of parallelogram. And I'm going to show you why you need to do that. If it is the area of a triangle you are asked to determine, after finding the magnitude of the cross product, just divide it by 2. So why do you need to do that? Because the half of a parallelogram is simply a triangle. You can see this white dotted line that I turned to a solid line serve as a diagonal that divide the parallelogram into 2, which one part of it is a triangle and the other part is a triangle. Since the whole parallelogram has been split into 2 equal parts, then its area will also be split into 2 equal parts. And that is why we will need to divide its whole area by 2 in order to have the half portion area, which will serve as the area of the triangle. And hopefully you got that, and that's actually how it works. So let's understand what we have been seeing lessons by putting into practice. Let's try to go over some examples. Number 1, find the area of a parallelogram whose boundaries are made up of vectors P and Q, and they are being defined with the corresponding components. When I said boundaries, they are referring to the edges like the base and the length. Okay? So now to find the area of the parallelogram, all we need to do is to find the cross product of vector P and Q. Then after determining the cross product, we need to find the magnitude, and that is the hint. So let's begin. We know that finding the cross product of two vectors, most especially when the vectors are defined in a three-dimensional plane surface, we need to make use of the determinant approach of matrices. If you haven't checked my video on cross product, then I will recommend you check it out. I will leave the link in the description of this video. So we are finding the determinant of vector P and Q. In the first row, that will be filled with the unit vector I, J, and K. Second row will be for the first vector P, and that will be 1, 2, and 2. All you need to do is just to take the components. Okay, that's 1, 2, 2. For the second one, that's going to be 2, 3, and negative 1. The component of the K axis is negative 1. Keep that in mind. Okay, perfect. Now, let's try to find the determinants. So, taking the unit vector I will need to ignore all elements below it, but include all elements excluding the one below it. That's going to be 2, 2, 3, negative 1. Okay. Then for the J unit vector, we need to associate it with negative. Okay. Then we have ignore the element below it. Just take the one excluding the ones below it. That's going to be 1, 2, 2, negative 1. Perfect. Then plus K. Then exclude this while you include all this. That will be 1, 2, 2, 3. So now you need to multiply. You multiply this and subtract it from the product of this. Okay, just watch. I in a bracket of 2 times negative 1, that's negative 2. 3 times 2, that's 6. Then minus 6. Okay, you multiply this, then you subtract it from the product of this. Minus J in a bracket of 1 times negative 1, that's negative 1. 2 times 2, that's positive 4. Then we are subtracting minus 4. Plus K in a bracket of 1 times 3, that's 3 minus 4. So subtracting that, we have negative 8I, then positive 5J, then negative 1K. So basically negative K. I hope you get how I got that. When you add this, you have negative 5. The negative here will affect it to become positive. When you add this, you become negative 8. Then you just multiply and have that. So now we need to determine the magnitude of this vector. To determine the magnitude, the area will eventually be the root of negative 8 squared plus 5 squared plus negative 1 all squared. And that will be in the end the root of 64, because negative 8 squared is 64, plus the square of 5 is 25, plus the square of negative 1 is 1. And adding this up, 2 plus 6, that's 8. This is 9, that's 10. That's the root of 100. Okay? Should it be the root of 100 or the root of 90? I hope I get that properly. So, I will leave that for you. If it is simplifiable, you simplify to the lowest term. It should be indeed simplifiable. Okay? Well, let me just do that. So, what two numbers that involve perfect square can multiply to 90? That should be 9 and 10. So, the root of 9 is 3. You bring it out. And we have 3 with 10. Final answer. And that is the solution to this problem. Now you know how to make use of vectors to determine the area of the parallelogram. And that is how problems involving such scenarios can come up. Hopefully you got that. Now let's consider problems involving finding the area of a triangle. Feel free to pause the video and check this one out. Sometimes vectors can be defined without associating the unit vector with it. Don't be confused and don't be carried away. Okay, just know that as these components, as they occur, that's how they are going to be making use of. Okay, for any component, it's going to be defined in the form of x, y, and z, which correspond to I, j, and k. Okay, so whatever value you see here, knows that it's like that of the component of I. Whatever you see here is the component for j. For here, it's component of k. And the good thing is that if it is defined this way, you can actually put it in this way for it to make things easy for you. So no one will question you for that. Okay, perfect. Now let's determine the area of the triangle. Let's try to draw a rough sketch of the triangle. So if this is a triangle, we are given the vertices, components of the triangle. So we actually need to make some adjustments before we can begin. So they said the triangle is defined as triangle PQR. The coordinates of Q is -12, 14, and 1. And that of R is -4, -2, and 1. And that of P is 4, -2, and 1. Okay, we only need this vector PR. Let me use different color. We only need this vector PR and that of vector PQ. However, you can determine the same thing by finding vector QR and that of RP. You see end up having the same answer. Okay, but for me, I'm just going to work with PQ and PR. Okay. Okay. Now to find PQ, all we need to do is just to we need to subtract those components respectively. -12, -4, that's -16. So PQ will have the following components: -16, then 14 minus 2, that's 16. Then 1 minus 1, that's going to be 0. Perfect. Now what about PR? To determine PR, that's going to be equals to, we need to be subtracting the component of R from the component of P respectively. If you don't really get it, you can actually check out my videos. I've created a video on that. Okay? But what it means makes sense is that if you have two vectors and they ask you to calculate something like PQ, you will be subtracting that of the component of P from that of Q, you understand, respectively. Okay, that's what it means makes sense. So PR will be component of R minus component of P. So -4, -4, that's -8. -2 minus -2, that's going to be -2 minus -2. That's -2 plus 2, that's 0. 0. Then 1 minus 1, that's going to be 0. Okay, perfect. So now I can get rid of this. Now I have the vectors I need to make use of to determine the cross product. So the area of the triangle now will be equals to half of the magnitude of the cross product of PQ multiplied by PR. Now there's one thing I would like to disclose with you before I proceed, before I move forward. You might be wondering why PQ comes first, followed by PR, because PR is serving as the base, while this is serving as the length. Well, notice that the cross product, though it is not commutative, which means PQ cross PR is not equals to PR cross PQ. But when we find their magnitude, they will eventually be the same. They will eventually be the same when we find the magnitude. The magnitude of PQ cross PR will be equal to the magnitude of PR cross PQ. So arranging those vectors anyhow, since I'm going to later on find the magnitude, won't affect my solution. That's what I want you to get right. Okay. If you are given two vectors and they say you should find the area of the parallelogram of triangle, you can arrange the vectors anyhow. Like any one of the components of those vectors can come first, followed by the other. That won't affect your answer. But if at all it's like the cross product alone, not that you have to find the magnitude, very, very sensitive about that, very, very careful. The vectors have to be arranged in order at which it is presented. Hope you got that, and hopefully that helps. So now I want to determine the cross product of this. So PQ cos PR will be equals to the determinant of PQ as the following components. Let me write I, J, K first. So that's going to be negative 16, 16 and 0, then negative 8, 0, 0. Perfect. So I'm running out of space. Let me get rid of this. Well, I don't really need this triangle anymore. I can get it as well. So therefore, for the I component, you already know what it is. Ignore this. Focus on this. So it's going to be 16, 0, 0, 0. For negative J component, ignore this. Okay. Then you focus on this and this. Okay. That's going to be negative 16, 0, negative 8, 0. Then for positive K, negative 16, 16, negative 8, 0. So now multiply. R in the bracket of 16 times 0, that's 0 minus 0, minus J in the bracket of 0 minus 0, K, plus K in the bracket of 0 minus, so 8 times 16. Well, I think I will need to use my calculator for that. So I got 128. So in the end, okay, it's going to be negative 128. So this is like 0i minus 0j, then plus 128k. So all of that component has become 0. Now, let me try to find the magnitude. Find the magnitude. So finding the magnitude of PQ cos PR is going to be the root of 0 squared plus negative 0 squared plus 128 squared. So which is the same as the root of 128 squared. So the squared cancel the root, we are left with 128. This is the area of the parallelogram, but we have to find that of area, so we need to find half of it. So the area of the triangle now will be equals to 128 divided by 2, which is 64 units. And that is our final answer. Square unit should be square unit because it's area. Okay. And that is our final answer. Now you know how to find the area of triangle and the area of parallelogram if the sides of the parallelograms or triangles are defined in form of a vector. Hopefully you find this helpful. Thanks for watching. See you guys in the next video. Bye for now.